Most people on the West Coast think they already know what the danger is. They picture the shaking. They picture a magnitude 9, the ground rolling under Portland and Seattle, glass falling, freeways buckling, and they file it away as something that will be terrifying and survivable. The reason seismologists lose sleep over the Cascadia Subduction Zone is not the shaking, it is the clock that starts the second the shaking stops. On the outer coast of Washington and Oregon, the Washington Emergency Management Division estimates that people will have 10 to 15 minutes from the end of the ground motion to the arrival of the first tsunami wave. That is the entire margin. Not hours, not a phone alert, not a siren network that buys you time. 15 minutes of walking, possibly in the dark, over ground that has just been torn apart, for tens of thousands of people who have never once timed the route. It has been 326 years since this fault last released, on the night of January 26, 1700, and the Juan de Fuca plate has been grinding east beneath North America at roughly 4 centimeters a year for every one of those years. That loading is happening right now, offshore, while you watch this. Subscribe before we go further, because this is a story I intend to keep updating. This is the part of the story that almost no one is telling. Before we get into the details, I want to be upfront about something. Nothing happened today. There is no alert on your phone, no earthquake swarm, no official warning of any kind, and if you go looking at the seismic feeds right now, you will find that Cascadia is one of the quietest major plate boundaries on Earth. On its own, a quiet fault is nothing unusual. What makes this worth a full breakdown is not a number on a magnitude scale. It is that the survival margin for the entire outer coast is measured in single-digit minutes, and a series of studies published between 2025 and this year have quietly shown that the margin is thinner than the evacuation maps assume. That gap is what the next 20 minutes are about. Here is what the agencies actually say, with the numbers attached. The Cascadia Subduction Zone is a fault roughly 1,000 kilometers long, about 700 miles, running from Cape Mendocino in Northern California past Oregon and Washington to northern Vancouver Island, according to the Pacific Northwest Seismic Network. It separates the Juan de Fuca plate from the North American plate, and the Juan de Fuca plate is moving toward the continent at about 4 centimeters per year. The last full rupture is dated to the evening of January 26, 1700, at roughly 9 in the evening local time, with an estimated magnitude between 8.7 and 9.2. The U.S. Geological Survey currently puts the probability of an approximately magnitude 9 full margin rupture at 10 to 15% in the next 50 years. For the southern segment alone, off southern Oregon and northern California, the numbers are much higher. Work by Chris Goldfinger and colleagues, published through the USGS, identified 41 events in the southern margin over the past 10,000 years, giving an average recurrence of about 240 years, and time-dependent probabilities in the range of 37 to 42% in 50 years for that southern segment. The Pacific Northwest Seismic Network counts at least 19 great earthquakes of magnitude 8 or higher across the whole margin in the same 10,000-year window, with a full margin average closer to 500 years. The USGS also estimates an 85% chance of a magnitude 6.5 or greater deep earthquake in the Puget Sound region over 50 years, a separate hazard running on its own schedule. None of those numbers are forecasts of a date. They are the shape of a system that is still loading, still being measured, and still being revised as new offshore data comes in. To understand why 15 minutes is the number that matters, you have to understand what is physically happening down there, because the mechanism is running as you listen to this. Picture two enormous sheets of rock in contact, one sliding beneath the other. In a healthy, noisy subduction zone like the one off Japan or Chile, that contact slips constantly in small increments, and the region gets frequent moderate earthquakes as the pressure bleeds off. Cascadia does not do that. The upper part of the contact is locked. The two plates are effectively welded together across a band tens of kilometers wide, and yet the plate behind them never stops pushing. Think of bending a plastic ruler between your hands. The ruler does not move, so it feels like nothing is happening, but every fraction of a second you are storing energy in it. That is the coastline right now. GPS instruments across coastal Oregon and Washington show the land being squeezed eastward and bowed upward, a measurable deformation that reverses instantly when the lock fails. Run the arithmetic and the scale becomes uncomfortable. 326 years at 4 centimeters a year is about 13 meters of accumulated slip that the fault owes. That debt does not get paid in installments. It gets paid in one motion, when the weld breaks and the leading edge of North America lurches west over the descending plate. Magnitude is where most people lose the scale, so let me anchor it. The magnitude scale is logarithmic, which means each whole number step is about 32 times more energy released. A magnitude 7 is not slightly smaller than a magnitude 9. It is roughly 1,000th of the energy. But the difference you would actually feel is duration. A sharp magnitude 6 lasts a few seconds because the fault patch that breaks is small. A full Cascadia rupture has to tear along 1,000 kilometers of plate boundary, and rupture fronts travel at something like 2 to 3 kilometers per second, which is why federal and state planners model 4 to 6 minutes of continuous shaking. Oregon's Department of Emergency Management uses 5 to 7 minutes along the coastline. Sit still and count out 4 minutes sometime. It is an absurdly long time for the ground to be moving, long enough that documented accounts of the 1700 event describe people unable to stand and shaking so prolonged that it made them sick. The tsunami is not a separate disaster, it is the same motion, seen from above. When the locked zone releases, the offshore edge of the overriding plate snaps upward, and it does so under 2 to 3 kilometers of ocean. The entire water column above it gets lifted, and water does not compress. It has to go somewhere. Simultaneously, the coastline behind that uplift drops. This is the part that surprises people. The land does not just shake, it subsides. 0.5 meter to 2 meters in a matter of minutes, according to modeling published by Tina Dura and colleagues in the Proceedings of the National Academy of Sciences in 2025. Beaches, harbors, and airstrips end up sitting lower than the water that is already on its way toward them. Then the wave crosses. In deep ocean, a tsunami is not a wall of water, it is a broad rise moving at jetliner speed, several hundred kilometers per hour, with a wavelength that can exceed 100 kilometers and a height at sea that a boat might not notice. It carries its energy in length, not height. When it reaches the continental shelf and the water shallows, the front slows and everything behind it piles into the back of it. The height converts from length. NOAA models a Cascadia tsunami reaching the coast in 15 to 30 minutes depending on location, with heights that may reach 30 to 40 feet, and Oregon's Emergency Management Agency plans for coastal run-up that can approach 100 feet in the worst configurations of bay and headland. That is why the same earthquake produces a survivable outcome 8 blocks inland and an unsurvivable one at the beach. None of this was known when most of the buildings on that coast were designed. Until the 1980s, the scientific consensus held that Cascadia was aseismic, a subduction zone that somehow slid quietly. The reversal came from mud and wood. USGS geologist Brian Atwater found buried marsh soils along Washington estuaries, layers where a living meadow had been dropped below the tide line in an instant and capped with sand. Dendrochronologists, led by David Yamaguchi, dated the drowned red cedar snags of the ghost forests and found their final growth ring complete for 1699, meaning the trees died in dormancy, between the autumn of 1699 and the spring of 1700. And in 1996, a team led by Kenji Satake matched that window to Japanese records of a tsunami that struck at least 6 sites on the Pacific coast of Honshu, with run-ups of roughly 1.5 to 5 meters, on a date that converts to January 27, 1700, with no local earthquake to explain it. Working backward through wave travel times, they placed the parent earthquake on the far side of the Pacific and fixed it to the previous evening. A whole hazard class was discovered in a single decade, and the coastline built before that discovery is still standing on it. But here is the part that almost no one is covering. The 15 minutes is not 15 minutes of walking. It is 15 minutes of everything, and the front end of it is already spoken for. A December 2024 study by Oregon's Department of Geology and Mineral Industries, examining evacuation options in Seaside and Cannon Beach, estimated that it takes an average of about 7 minutes for people to gather family members and belongings and actually begin moving, and then added roughly 3 minutes for the shaking itself. 10 of your 15 minutes are gone before the first step. And Washington's own modeling is tighter than the headline number. State Department of Natural Resources simulations released in 2022 put the first rising wave at La Push within 10 minutes of the start of shaking, Moclips, Copalis Beach, and Nia Bay at around 20 minutes, Clallam Bay at 30, and Port Angeles inside an hour. Meanwhile, the evacuation guidance from NanoUS and Oregon State modelers notes something that rarely makes it into public messaging. Flooding caused by the sudden regional subsidence of the land can precede the first wave arrival by 10 to 15 minutes. Parts of the low coast may be taking on water before the tsunami ever gets there. This is where the story gets genuinely complicated, because the subsidence is not just a timing problem, it is a permanent one. The Dura team quantified what happens to the 1% floodplain, the area with a 1 in 100 annual flood risk, across 24 Cascadia estuaries. Under their scenarios, a great earthquake today would expand that floodplain by 90 square kilometers at low subsidence, 160 at medium, and 300 at high. In concrete terms, that is an additional 14,350 residents, 22,500 structures, and 777 miles of road that end up inside a flood risk zone the moment the shaking stops, more than doubling current exposure. Project it to 2100, when sea level along that coast may be up to 3 feet higher, and the expansion runs to 170, 240, or 370 square kilometers. Dura's own framing is that the immediate effect is a delayed response and recovery. because the assets you would use to recover are compromised, and the long-term effect could render some coastal communities uninhabitable. The tsunami retreats, the new coastline does not. Now consider the technology that most people assume will save them. ShakeAlert, the West Coast Earthquake Early Warning System, finished its planned build-out this year, with the Pacific Northwest Seismic Network confirming 569 seismic stations across Washington and Oregon. It works. It is genuinely one of the best public safety systems built this century, but USGS analysis is blunt about what it delivers for an offshore megathrust, warning times generally ranging from seconds to tens of seconds, with 50 to 80 seconds possible only for users far from the rupture, and every one of those sensors is on land. At the 2026 meeting of the Seismological Society of America, Zoe Kraus of the University of Washington and PNSN presented work showing that folding in existing cabled ocean bottom seismometers off Oregon and Vancouver Island could improve detection time by 5 to 9 seconds, and that distributed acoustic sensing across all 18 known offshore cables could push that to 18 seconds in some locations. The Cascadia Offshore Subduction Zone Observatory project is installing 4 new instruments this summer. Those are real gains and they matter. But look at the units. The best available engineering buys you seconds. The tsunami is a 15-minute problem. No sensor extends that window. Only your legs do. And then there is the reassurance trap, which is the most dangerous development of the past year. In October, a team led by Brandon Shuck at Louisiana State University published imaging from the 2021 Cascadia Seismic Imaging Experiment, showing tears in the subducting plate off Vancouver Island. One slab segment dropped by more than 3 miles. The framing that traveled fastest was that Cascadia is dying, that the subduction zone is shutting down. Headlines followed. But in April of this year, structural geologist Alexander Peace of McMaster University published a direct correction of that interpretation, arguing the science says something different and more complicated. The northern end is fragmenting piece by piece over geological time, while the remaining plate continues to subduct. Cascadia remains an active subduction zone capable of producing large earthquakes. If you absorbed the comforting version of that headline and quietly downgraded your own risk, you absorbed the wrong story. That is still true as you watch this. There is one more layer, and it is human rather than geological. The Federal Emergency Management Agency's 2022 Region 10 plan covers 27 counties and 453 miles of coastline, 157 miles in Washington and 296 in Oregon. Washington's own vertical evacuation assessment found the state needs somewhere between 25 and 40 refuge structures in Pacific County alone, 30 to 42 in Grays Harbor, and 1 to 3 in Clallam County, against a starting inventory of 2. In Oregon, the report following the 2016 Cascadia Rising exercise projected that Clatsop County would see the highest tsunami death and injury toll, with an estimated 4,000 casualties in the city of Seaside by itself. Clatsop County had secured more than $20 million in federal resilience funding to retrofit its rural hospital, which sits inside the inundation zone, and the cancellation of the BRIC program left that project without its money, according to reporting from the National Association of Counties last August. The physics has not changed in 326 years. The preparation is what moves, in both directions, right now. Let me make this concrete with the one account we have of what a full Cascadia rupture does to people who live on that shore. At the north end of what is now the West Coast Trail on Vancouver Island sits Pachena Bay, home to the Huayot village of Anakla. In 1964, shortly before his death, Chief Louis Nookmias told the story his grandfather had told him, an account later cataloged by University of Washington seismologist Ruth Ludwin in a 2005 survey of Indigenous oral histories of the event. It was night. The land shook. The people of the beach village had no time to reach their canoes and no time to wake. A great wave came into the bay in the dark and, in his telling, not one of them survived. The only Huayot who lived were the ones at an upland site called Malutsas, house up against hill, who did not drift out to sea with the others. Natural Resources Canada's own historical record of the January 26, 1700 event states plainly that the winter village of the Pachena Bay people was completely destroyed, with no survivors below roughly 75 feet of elevation. Elevation was the entire variable. It still is. And the detail that stays with me is what the Huayot did with that inheritance. Their modern administration building sits on high ground above the bay, placed there on the advice of elders who kept that number alive in the story for 3 centuries before science ever named the earthquake. That building is up there today, waiting for a wave that has not arrived yet. To keep this danger properly in proportion, look honestly at the base rate. 19 great earthquakes in 10,000 years across the full margin works out to an average interval near 500 years, and by that measure 326 years is not overdue. It is well inside the normal range. The southern segment tells a harsher story. with 41 events and an average interval close to 240 years, which is why Goldfinger's group calculated that by 2060, Cascadia will have exceeded about 27% of Holocene recurrence intervals in the north and 85% in the south. Both statements are true at once. The north is not late, the south is running past most of its historical intervals. Here is what the data does and does not tell us. It does not tell us a year, a season, or a decade. Great subduction earthquakes generally arrive with no useful precursors, and no scientific body on Earth can issue a short-term prediction for Cascadia. Anyone giving you a date is selling something. What the data does tell us is a probability distribution, currently 10 to 15% in 50 years for a full margin magnitude 9, and roughly 37 to 43% for a magnitude 8 or larger in the south, and those are not small numbers for an event of this consequence. The instructive contrast is Tohoku in 2011. Japan had the most sophisticated earthquake warning and seawall infrastructure on the planet, and still lost more than 20,000 people, the overwhelming majority to water rather than shaking, because the design assumptions were built around a smaller earthquake than the one that came. Compare that to Chile in 1960, the largest instrumentally recorded earthquake in history at magnitude 9.5, where roughly 1,650 died, or Alaska in 1964 with around 140 deaths, or Sumatra in 2004 with an estimated 280,000. The variable separating those outcomes is not magnitude. It is how many people were standing in the inundation zone when the water arrived and whether they moved on their own without waiting for permission. FEMA's Region 10 modeling for a Cascadia event tomorrow projects more than 13,800 deaths and 107,000 injuries, with economic impacts across 3 states exceeding $70 billion. Those are not prophecies. They are the arithmetic of current preparation levels, and preparation is the one term in the equation that individuals can still change. So here is what actually moves your odds, and every item on this list is something you can do this week. First, find out whether the ground you sleep on is inside the tsunami inundation zone. The NANO's visualization system, Oregon's Dogami maps, and Washington DNR's evacuation maps let you check an exact address. Do not guess based on how far the ocean looks. Second, once you know, walk the route to high ground and time it with a stopwatch, at night, in bad weather. If the walk takes longer than 10 minutes, you need a different destination, and you need to know that before it matters rather than during. Third, treat the shaking itself as the warning. On the outer coast, there will be no official alert with useful lead time. When the ground stops moving, you move, immediately, without waiting for confirmation from anyone. Fourth, and this is the counterintuitive one, do not plan to drive. Coastal roads will have liquefaction damage, bridge failures, and downed lines, and a mass vehicle evacuation on a 2-lane coastal highway converts a 15-minute walking problem into a permanent traffic jam inside the flood zone. The I-5 bridge over the Columbia is expected to fail in this earthquake in its current condition. Walking is not the fallback plan, it is the plan. Fifth, put shoes and a headlamp where you can reach them from bed. The 1700 event struck around 9 in the evening. An evacuation that begins with bare feet on broken glass in the dark does not finish in time. Sixth, locate the nearest vertical evacuation structure if there is one, and accept that in most communities there is not one yet. Ocosta Elementary near Westport was the first in Washington, and the state assessment says dozens more are needed. Seventh, prepare for 2 weeks of self-sufficiency rather than 72 hours. Oregon's Emergency Management Agency is explicit that coastal populations will be isolated into islands by landslides, liquefaction, and destroyed bridges, and the Oregon Resilience Plan estimates 3 months to a year to restore full service in the western valleys and considerably longer on the coast. Water, medication, and a way to purify more matter far more than a flashlight. Eighth, enable earthquake alerts on your phone through MyShake or your built-in Android settings, understanding exactly what they buy you. Seconds to drop and cover, not minutes to run. None of this is a story with an ending yet. Over the coming weeks, I will be watching 3 specific things, and I will bring you each of them. The first is the offshore instrumentation, because the Cascadia Offshore Subduction Zone Observatory is installing new ocean bottom seismometers this summer, and every second those add to ShakeAlert detection is a second bought for the whole coast. The second is the USGS and Pacific Northwest Seismic Network probability updates, which have been revised upward as time-dependent modeling improves. The third is the evacuation mapping from Dogami and Washington DNR, which is being rewritten right now to account for the subsidence numbers. If you want those updates as they land, subscribe, because the next revision of these maps will change what some of you need to do about the house you are sitting in. 326 years of loading is not a countdown clock, and it is not a promise about tomorrow. It is a system that has never once failed to finish what it starts. Know your elevation, time your route, and stay safe out there.